All right. So for chapter 9, next up is 9.3. We're doing surface area of pyramids and cones. So getting to some funner stuff. So we're going to differentiate between lateral surface area and surface area of pyramids and cones. And we're going to apply formulas. We're not actually going to derive any formulas today. So if my pen would work, we'd be in great shape. Okay, so we're going to apply formulas for the surface area of pyramids and cones. So first up, the altitude. Do you guys remember the altitude? Okay, we talked about altitude of triangles and things. Now we're talking about the altitude of a three-dimensional figure. But it's a segment from the vertex, because we're talking pyramids and cones. So there's one vertex. Okay, so it's from the vertex and it's perpendicular to the base, or to the plane of the base. Okay, altitude's length is the pyramid's height, is another thing to think about. All right, so then we have slant height, which is L, like the L in slant. Okay, it is the height of the triangular lateral face. But we do need it because we're going to use it to calculate the area of a lateral face. So we have to know the difference between the altitude, or we might call it the height. Most of the time it's going to be altitude versus the slant height. Okay, and then our theorems today are going to be very helpful. Okay, so we have the lateral surface area, first of all, of a regular pyramid. What's regular mean? What does normal mean in mathematical terms? There's no such thing as normal. What's regular in math? A regular polygon, a regular pentagon, all the sides are equal. And a regular pentagon, okay, and any regular polygon, even though it's not really a regular polygon, all the sides are equal. That's what regular means. So if this is a regular pyramid, along the base, all the sides of the base are equal, which makes everything else equal. Okay? Good try. So we have a couple of, the lateral surface area here is L equals 1/2 P times a lowercase l. What's the P stand for? Perimeter. What's the lowercase l stand for? Not length. Slant height. Okay. So P is perimeter, L is slant height. Now its surface area, okay, is different. S is equal to 1/2 P, still perimeter, times the quantity L, we talked about as a slant height, plus A. A is the, not the area, it's the apothem of the base. Well, not in this case.
What do you mean an apothem?
Apothem, remember, again, if we go back to the, if we go back to other, do you know what it is? When we have a regular polygon, the apothem is from the vertex down. It's 90 degrees from the center. Is the apothem. So like in this case, what is your apothem in this example up, or that's, well, it's labeled A. I guess that doesn't really help you. Okay. So your altitude, I put up here a little lowercase a or a lowercase h, would actually be labeled with an uppercase H. The lowercase goes to the two-dimensional. The uppercase is usually the three-dimensional. All right, the next theorem, your lateral surface area of a circular cone is L, so for lateral surface area, equals 1/2 C and lowercase l. What's the C stand for? Circumference, because it's a circle. Yep, so C is the circumference, which is also down here, right? C is circumference. And what's the lowercase l? Your slant height. Okay, and then your surface area, we have S equals 1/2 C, your circumference, times the quantity L plus R, your slant height plus your radius. So there are kind of some uglier formulas today. And the last one, the surface area of a cone or pyramid, you could also say is just the sum of the lateral surface area and the area of the base. So it's still the surface area is S equals S plus B, or L plus B, pardon me. Okay, so we could also keep that same one. It's just what we plug in there for our lateral surface area and what we plug in for our base.
Why isn't it S equals L plus 2B?
Because it's a cone or a pyramid only has one base this time, where a prism had two bases. Good question, though, as to why there's only one B. All right, so then let's go on down and start applying these, because that's the hard part today, is putting these into practice. So find the surface of a surface area of a regular pyramid. Okay, and we can look at this using either formula. So which one do you want to start with? Or which one do you want to use? Okay, so if we use it directly from there, 1/2 P L plus A. All right, so we need to find our perimeter. We know that it's a regular pyramid. What does regular mean? All sides are equal. Good. Okay, so how long is each side?
7 inches.
7 inches. How many are there?
5.
So our perimeter equals 7 times 5. Sorry, it's supposed to be 7 times 5 because there's 7 7. The length is 7 and there's 5 of them. So 7 times 5. Good. Then we need L.
Would that be the 16?
That would be the 16. Very nice. And we need the apothem. You got it. So in this case, it's super simple to plug that all in, right? Our surface area is going to equal 1/2 35 times the quantity 16 times 4.8. Thank you, plus 4.8.
Also aggressive. Plus.
It's okay. Do the math.
It would be 35 times 20.8.
Yep. Or half of that. So if you wanted to do 20.8, do 10.4. 35 times 10.4. 364. Anybody confirm that?
Well, it's not a leap year. So.
Good call. So that'd be 365. Is a regular year.
No, 364 is a regular year. 365 is a leap year.
365 days is how many is in a year. 366 is in a leap year.
It was just negative leap year.
There you go.
364.
Okay, we got confirmation. So surface area is 364 inches squared. Now, again, you could do the other formula. It also said that S was equal to the lateral surface area plus the base. Okay. If you do that, then you have to find the lateral surface area. Okay. So what shape is this lateral surface? No, just one surface. It's a triangle. So the lateral surface area would equal 1/2 of
7 times 16.
well, not 7. Wait, 7 times 16. Why did you say? Well, it's still the perimeter times the slant height. So it would be 35 times 16. Because if you're looking for the lateral surface area of a triangle, the formula comes back to 1/2 PL. And then what about and so this would equal, what's 1/2 times 35 times 16? 8 times 35. 280. Okay. And then we would have to find the area of our base. What shape is our base? pentagon. Anybody remember the area for the formula for the area of a pentagon? For any regular, nope, for any regular non-gon, it's the apothem times the perimeter.
So it'd be 4.8 times 7.
The perimeter was not 7. The perimeter of the base
35.
was the 35. So half of 4.8 times 35 is what? You can kind of see it on here. No?
168.
I did not get.
98.
I didn't get either of those.
Oh, I forgot to do that.
Half times 4.8 times 35.
Oh,
We forgot to do that.
37.5. Yeah.
84.
Thank you. All right, so now that I have my lateral surface area and the base area, all I have to do is add them. So it's 280 plus 84, which equals 364 inches squared.
What?
280 plus the plus sign in there. Otherwise, it wouldn't equal 364. So either of those, you can use either one. It's just if you go down to that third theorem, 9.3.3, the S equals L plus B, you have to go look up all the parts. Like what's the area of a triangle? And then, or the lateral surface area for triangles, and go from there. Okay, which is good practice for 2. We want to find the lateral surface area and the surface area this time for the regular pyramid, which you had to find both anyway, so it doesn't really matter that much. Okay, and we know it's regular again. So what's the formula for the formulas that we need to use? What's that? L equals 1/2 PL. Okay. And what about our surface area?
S equals L plus B.
Okay, we could use S equals L plus B. That works. All right, so let's find our lateral surface area. We said P is perimeter, so what's our perimeter?
72.
How'd you get 72?
Because I did the perimeter.
How did you do the perimeter?
I counted all sides and there's 6, so you do 6 times 12.
There you go. Okay, so 6 times 12 equals 72.
L equals 23.
And our slant height, L equals 23. So our lateral surface area is 1/2 72 times 23.
828.
Anybody confirm 828?
Yep.
Yes? Okay, sorry, I was trying to get my calculator on my phone out. All right, so we got 828. What's the unit of measurement here? Inches squared. Good, because it's area, lateral surface area. Okay, perfect. So that's one of our final answers, right? Was the lateral surface area. Now we need to find the surface area of the regular pyramid. So the lateral surface area, what did I find? What did I just find the area of?
The lateral surface area.
What is that? Is that the area of the hexagon or the area of all the triangles? All the triangles, right? It's the lateral. It's the stuff that's coming up. Good. All right, so now surface area. Well, we've got the lateral surface, right? 828. But now we need the area of the base. We don't know the apothem. Huh. Okay. There is no other one.
Yes.
No.
S equals 1/2 P parentheses L plus A.
But you still need the apothem.
And you don't.
A is the apothem. It's okay. All right, so here's the thing. So then we have to think about, well, the base of this, we're going to look at this. I drew a picture of the base. It's a very bad picture, but that's okay. And we know it's a regular hexagon, and each side is 12 inches. We have to use our geometry background to calculate the apothem. What did we talk about? I drew a picture earlier when we said, like, wait a minute, what's the apothem? I forgot. What was the picture? What is an apothem? It's the center to an edge, yes. Okay, so what I'm going to do is I'm actually going to draw this, like, cut this into 6 equilateral triangles, right? Looks more, maybe, right? Okay, the apothem is not a radius, like the radius, right? It's not from the center to a vertex. It's from the center perpendicular to the side. All right, since these are, what kind of triangles are these? Since it's a regular hexagon, they're equilateral. Okay, so if this edge is 12, how long is this edge here?
12.
This is 12, and this side is 12. If I drew a perpendicular or an angle bisector here, the whole side is 12, but I don't.
6 and 6.
6 and 6. There we go. Okay, so we're using that previous geometry background. And now I want to find my apothem.
8.
It's not 8. Remember, but what kind of triangle do I have here?
Right. Do Pythagorean.
I have a right triangle, so I could do the Pythagorean theorem. Okay.
6 squared plus b squared.
Okay, well, I'm going to call it a squared because my apothem is a.
Okay, whatever. Equals 12 squared.
All right, so then 36 plus a squared equals 144. Then what? We're trying to find a, our apothem. What'd you do?
B squared equals 108.
Okay, so we subtract 36. So we have a squared equals 108. Square root?
Yep, square root.
Okay, so then we do the square root. So a equals,
Approximately 10.3, 10.4.
okay, approximately 10.3. I'm going to write it as 6 times the square root of 3, depending on what your calculator can do. All right, so now I have my apothem. Now, if any of you remembered the shortcut,
The square root of 2 or 3?
sorry, the square root of 3. I said 2. If any of you remember the shortcut, this is of this 90-degree triangle. It's a 30, 60, 90, because this would be 60, and this would be 30 up here. Then it was x, 2x, x times the square root of 3. So it would have been x. We could have also done it that way.
But can't that be like a 61 and a 29?
It's an equilateral triangle. It's a hexagon. That was, so 360 degrees total, broken into 6 equilateral triangles, so each one is 60 degrees. And so when we split it in half, we end up with a 30, 60, 90. Totally fine that you didn't see that. Okay? Totally fine. This is what I would have done anyway to check myself and make sure. Okay? But if you were made that connection, that is awesome. Okay? But not required. All right, so now for the area of the base, what did you say the formula was? It was 1/2 a times p. Was that right? 1/2 a times p. Yeah, for the base of any shape. Okay, so now we finally have our apothem. So it's 1/2 6 times the square root of 3 was our apothem. And what's our perimeter? 72. It's still the same as what it was up here. We're talking about the same shape. So what's 1/2 times 6 to the square root of 3, or approximately 10, times 72? Did you do your square root of, so on this calculator, you may have to do like your, where's the square root again? Okay, so do you have to do 108 square root? Okay, and then times 0.5, and then times 72. Yeah.
So approximately 374.
Mm-hmm. Okay, so 374.12, we'll go ahead and put. All right, so that's our kind of intermediate answer. Now we're ready to put that, right? So now our surface area is going to be the 828, our lateral surface area, plus our base area. So what does that equal?
1,202.
And it's still inches squared. So these are going to take a bit longer.
Did you not have as many?
I was just thinking about that potentially. Okay. Are we ready for the back?
1, 2, 3. Oh.
Ha 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 ha.
Multiple screws.
What? Oh, there it goes. Okay. So next up then, we're going to do a cone. Find the height. This time we're finding the height, okay, of the circular cone if its surface area is 144 pi centimeters squared.
So,
Okay, so what's the formula for the surface area of a cone?
so
Well, we don't want L, we want lateral surface area, we want S. C times the quantity L plus R. Okay. All right, look.
S would be 144 pi c squared.
Okay, so it's going to be 144 pi. Good, equals 1/2. We need to find our circumference, don't we? Okay, so what's the formula for circumference? 2 pi r. All right. And what's our radius here?
6.
6. So 2 times pi times 6, which would be 12 pi. Okay. So we're going to have half of 12 pi times L. What's L? We don't know. Okay.
So that's what they have mind, right?
Plus our radius. So we are finding L here.
Cancel out the pi's.
The pi's, good catch, can cancel out, right? There's a pi on both sides, so we can just cancel those. So when we got 144 equals half of 12 is...
Well, you'd multiply by 2, but...
I wouldn't. I would divide the 12 into a 6.
I would do half of 12 as well. And just say what's half of 12 and get 6.
Then would you divide the 6's or...
Yep. Divide by 6. Yep. What's 144 divided by 6?
24.
So 24 would equal L plus 6.
No, you divided the 6.
No,
Nope.
there's still another 6
Oh,
there.
okay.
Yeah.
So then you subtract that 6, which would be 18. L equals 18.
Okay. So what is L?
18.
18. But L stands for what?
Centimeters.
It is centimeters. Great.
H.
Not H. It says equals L. What is L?
Slant height.
The slant height. So the L, like over here on your diagram, it is an L. This is 18, but it is not the height of the cone. It's the slant height of the cone.
So now do we just plug it back in, or
Well, how would you plug it back in?
put A to where L was, and 18 where L was?
But see, that's the thing. In this formula that we use, there is no height of the cone in this formula. So we found what we needed to find. Like we used the formula for the surface area because that's what we had. There was only one unknown, so we found it. But now what? Right? Because we're looking h, the height of the cone is this value. So how are we going to find the height of the cone? Pythagorean theorem. Because we have a triangle here. Okay, between the radius and the slant height and the height of the cone. So we can use the Pythagorean theorem.
So it's just 6 square root of 3.
Well, it's going to be 6 squared. Oh, you're saying the answer is just 6 square root of 3?
Because isn't that a 90?
But it's x 2x times the square root of 3. This is not a 2x, right? Because that would have to be 12. So then we know it's not a 30, 60, 90 triangle. Good call, though. So it's some other measurement. But I like the way you were thinking to try to take that shortcut. So it's going to be 6 squared plus h squared equals 18 squared.
Is 18 squared 156?
No.
What is it?
It's much bigger.
Oh, yeah, it is.
Because 20 squared is 400. So it's going to be closer to 400.
356.
Not quite.
What is it?
8 times 8 would not give you a 6.
So the squares cancel out.
The squares do not cancel out, so we have to do them. So, right, 36 plus h squared equals 3. Did you figure it out yet?
364.
24.
Yeah, that's what I said.
Yeah, that's what you said.
Oh, it is, huh?
Then we subtract 36. We have h squared equals 288. Then what?
Square root.
Square root. So h equals
Approximately 17.
12 times the square root of 2, which is approximately 17 centimeters. That is your final answer.
And that's just for one question.
That's just for one question. You keep trash talking how ridiculous it is. I'm going to leave all 31.
30?
Well, it's 1 to 31 odd.
15?
Yeah, I was like, it's only 15 problems.
Yeah, but like, if we take like 20 minutes on each question, we took 20 minutes on this one.
We did not take 20 minutes on it, you whiny babies.
You turn the page and I'm like, oh.
Okay.
There's still some things at the bottom. Then we gotta go to example 4.
All right. So there's some formulas here to help you, right? So you have them handy in your notes. But the other thing is the Platonic solids. Okay. So there are 5 regular polyhedra, or they're called Platonic solids. Again, what's the word regular mean?
All sides are equal.
All the sides are equal. Okay, so no longer do we just talk about a square or a cube. It's not the only Platonic side. If you have a 3-sided dice, some of you have seen those, or you've seen a 12-sided dice, those are regular polyhedra or Platonic solids. Okay, so each face is congruent. All the sides, same thing you said, all the sides are equal. So each face is equal. And the same number of faces intersect at each vertex.
They do.
Here's the thing. The surface area of a Platonic solid is S equals N times A. N is the number of faces. A is the area of each face. Okay? Or we have the surface area of a cube, which we talked about in our homework and pulled out that formula as well. So, it's kind of a cool example. Blake here sells calendars in the shape of a regular dodecahedron. Dodeca is how many sides?
10.
Dodeca.
12.
12. Deca is 10. Do is like dos in Spanish. So dodeca is 12 sides.
Wait, so
or 12 faces.
Icosahedron is a 27.
Isohedron?
Icosahedron.
Oh, yeah.
Probably.
We were talking about that the other day. Gotcha. All right. So you want to find the total surface area of a calendar if each face has an edge of 1.8 inches and an apothem of 1.1 inches. So first of all, what's the formula to find the surface area of a Platonic solid?
S equals
Okay, NA. And what's the N stand for? Number of faces. So how many faces are there? 12. And what does A stand for? Area of each face. Okay, so how do you find the area of this face? First of all, what's the shape of the face? It's a pentagon. So how do we find the area of a pentagon? Area of a regular n-gon.
Doesn't say each like side of the face is 1.8.
It does, but we have to have the formula to find the area. So it's 1/2 the apothem times the perimeter. All right. And so you're right. It tells us that. How big is the apothem? 1.1. So the perimeter is 1.8 times 5. We didn't find the perimeter first. Well, you did say that it was 9, and it is 9. I'm just saying, like, but if we say 9, where do we get it from? So, like, if we need to work that out, perimeter is the distance around this. Each one of these is 1.8, and there are 5 of them if we need to break it down. So our perimeter is 9. However you want to put that into your equation is fine with me. If you want to put it in this step or if you want to do it separate, does not matter. But do we understand where the perimeter came from? The perimeter of the face, okay? All right, so what's 1/2 of 1.1 times 1.8 times 5? You all have a calculator, and yet you're staring at the board.
What?
What is the problem? The math there? 1/2 times 1.1 times 1.8 times 5. Okay, can anybody confirm 4.95? This is part of why the math takes so long.
What did you say?
4.95. Okay. But this is part of why it takes so long in class is because you guys you're not doing the math in the calculator as we're working. Like you wait for me to stand here and then say, what is the math? Okay, so now that we have the area, we're ready to put it into the other formula for surface area. So our surface area equals 12 times 4.95. Can anybody confirm 59.4?
Yep.
Okay. All right, so there you go. The formulas aren't necessarily hard, but inside each formula there's like another formula or another formula or another formula. So you have to build them all together. Okay, that is definitely the hard part about today's lesson, is putting those all together.